the standard normal distribution. Our normal distribution is defined by this exponential function in which the bell is centered at mu and has standard deviation sigma that can be represented in the plot like mu is the mean of the distribution, and the thickness of the bell is represented by sigma. So this point will be sigma mu minus sigma, and this will be mu plus sigma. So this is the thickness of our bell. Now, for purposes of computation in tables, we define the z-score. So the z-score is a normalization of the Gaussian distribution. How do we standardize and normalize? Well, we define a variable that is going to be given by x minus mu divided by sigma. So we define z as x minus mu divided by sigma. Okay, so by defining like minus mu, so we are moving our function to the origin, and by divided by sigma we are normalizing, so we are dividing by the magnitude of the standard deviation. So the magnitudes now are going to be in the order of 1. So our new function, it will be centered at the origin, so mu is equal to 0, and the standard deviation, it will be equal to 1. Why 1? This will be minus 1, and that will be plus 1. So the equivalent points, mu minus sigma becomes minus 1, mu becomes 0, and mu plus sigma became 1. Yeah. Now, the reason is because when we convert to our different units, so now will be f of z, it will be equal to 1 divided by square root of 2 sigma pi e to the minus 1/2 of z squared. If we want our integral of f of z in between minus infinity to infinity with the corresponding change of variable, this should be equal to 1. So to keep this equal to 1, we need sigma squared to be equal to 1. So sigma is equal to 1. So our new function f of z in terms of the z-score is equal to 1 over square root of 2 pi multiplied by e to the minus z squared over 2. And this function is usually found in tables in books. Now let's have a look to one example. We have aluminum sheets that are used to make a beverage, and beverage can, not a beverage, and the thickness is in thousandths of an inch. We have that the mean is 10,000 of an inch and the standard deviation is 1.3. So we select one particular sheet and that measured 10.8 thousandths of an inch. We need to find the z-score for that case. So we need to convert from x to z. So according to our definition, we have that z is equal to x minus mu divided by sigma. So in this case will be x 10.8 minus mu, which is 10, divided by sigma, which is 1.3, and this is equal to 0.62. So this is our value for Z for the corresponding 10.8. As a final remark, notice that C doesn't have units, it's unitless. Okay, the opposite is also possible. So let's suppose that we have a thickness given in Z score, and the thickness is minus 1.7, and we need to find out what is the thickness in the original units. So we have that Z is equal to x minus mu divided by sigma. Therefore, we can solve for x, and we have that Z sigma is equal to x minus mu, so x is equal to Z sigma plus mu. So in our particular case, we have that x is equal to Z, which is minus 1.7, multiplied by sigma, which is 1.3, plus mu, which is 10. So the final result is that x is equal to 7.8, and the units are 10 to the minus 3 inches. Finally, how can we use this in practice to compute probabilities? Let's suppose that we need to compute the probability of x being less than 10.8. So we either can use the full exponential function and do the integral, or we can use the z-score and compute the value looking at tables of the standard normal distribution. Okay, so these tables of cumulative normal distribution work in the following way. So we have the z-score, and the z-score is for example 0.21. We have 0.20, and the cents are in this case, so 0.21 is equivalent to this value. So the z-scores are given in these two axes, and inside the value that we have is the integral from minus infinity to z of f of z dz. So this is the value that we have for a given z. So if we want to compute the probability of x being less than 10.8, so the first thing is we compute the z-score. So we know that the z-score of 10.8 is 0.62 from previous problem. So now we can compute the probability of x being less than 0.62, and that value we can find it in the table. So to compute this integral, so we look into the tens and the cents. 0.62, so 0.6 we look in this side, so that will be given by that row, and the 2 cents are in the 2 cents. So the intersection, it will give us that value. So the integral from minus infinity to z equal 0.62 of f of z dz is equal to 0.7324, and that represents the probability that z is less than 0.62, or the probability that x is less than 10.8 thousandths of an inch.